Welcome everybody. What you see now is a RapidMiner start screen. We're looking at different options, what we can do when we want to get started. So let's start from top to bottom. There's a set of introductory videos that you can use to get more familiar with the graphical user interface of RapidMiner and also for getting used to how to design a data mining process in RapidMiner. Obviously, we don't want to watch the videos together. You can do that offline, but I just wanted to point you to them. Furthermore, there's a set of tutorials that guides you through different steps. So if you want to hands-on work with the tool, and while you work with it with simple examples, learn the different aspects of the tool, like accessing data, filtering, sorting, pre-processing data, creating models, applying models, etc. You have tutorial modules available that give you pointers, where to click, what to do, and thereby you are easily learning how to use RapidMiner. So you can see for more advanced topics like handling missing values, outlier detection, pivoting, aggregation, looping, etc. And then of course also for the modeling and scoring aspects, as well as for validation, for example cross-validation, and of course at the end also visualizing the results, visualizing performance of models, how well they score on previously unseen data, as well as how they compare if you have several models and you want to know which is the best. Well, let's go one step further. You can do the tutorials and the videos offline when we're not in the webinar. Now, let's say you want to get started quickly and you have a particular task you would like to solve. For example, you have a set of customers and you have products you would like to sell more. Now you wonder which customers you should send an advertisement to trigger a buy decision. And obviously you don't want to spend budget on customers that wouldn't buy even if they receive some advertisement, especially if it's like a printed mailing where you would have to pay the printing and the mail delivery. And also you don't want to annoy existing customers or contacts. So the task, for example, would then be called direct marketing optimization. I just clicked on that little button and now what I see is a so-called application template. It's already a predefined process. It loads some demo data. I could easily replace it. So when you look here, this steps loads a data set. I could replace it by loading another data set or even loading it from a completely different source. So let me walk you through the left-hand side a little bit before we continue with the actual process. Each process is made up of a set of what we call operators. You could also call that steps in the process. So each little rectangle corresponds to one step in the process. I've just highlighted the load data element, and there's others for data preprocessing and modeling coming later on in the flow. Then you have the connections between the processes which indicate the data flow. And now if we talk about data access, for example, maybe you want to access data from a certain file type. You can see that a lot of different file types are readily available in RapidMiner. Or maybe you want to load data from a database. Our database operator connects to all standard SQL databases and also to some exotic ones. We also have connectors for NoSQL, for cloud-based sources, etc. So there's a lot of different data sources you can load the data from. You can also merge it from different sources. But let's start with something simple first. Let's just stick to that data set. In this particular next step, we perform some pre-processing. We want to tell the system that certain columns should not be used for the modeling. So for example, if I have a column that's like an ID, for example, the name of a customer, I don't want that to be part of my model because my prediction should not depend on whether someone's named Peter or Mary, but rather on other properties that are more indicative of the particular decision I want to predict. And then we see that the process splits into multiple branches. One is calculating weights, that is calculating the importance of an attribute with regards to the target variable. The target variable here is whether the person is going to buy something if I send them my mailing. Obviously, to be able to predict something like that, I need to generate a predictive model. And for that, again, I need data from the past where I've observed my customers and which type of customer reacted in a positive or negative way to my campaigns. And from that information of the past campaigns, the system can automatically rank the attributes of the customers and tell me which indicators are the strongest indicators with regards to my target. which is predicting whether the customer will buy or not. So this will be one output, what we were going to see. Another branch of the process performs a validation, which inside creates the predictive model and automatically validates it as well. So we'll see that in a moment as well, and I explain that in more depth shortly. Then we also apply the model and present the result at the end. Let me just add a few more connections here. I'll explain you shortly what we will see then. So I can run this process by just clicking the little play button up here, which executes the process and provides me all the results. For example, I can look at the data set, or maybe I should, let's go back for one little second and let's stop the process before we see all the results. I would like you to see the data we start with. So the initial data looks somehow like this. So we have the name of a person, we have some additional attributes about the person, whether it's a male or female, we have the age, where someone lives, is it more in an urban or rural area. We have some other information, whether they're using our free or premium email service, whether they're using a mobile, how often they use it, and we have the number of logins that they had in the last couple of weeks or months. And given all that information, obviously learning from the name should be excluded, we saw that already, but based on these other attributes, you would like to predict for new customers whether they will buy something or not. So the response yes means the customer actually bought something, and no meant he didn't buy anything. This is the data from the past that we're feeding into the system, so that's the very first step. Let me remove the stop point again, and let's go back to the process, and let's look at the results. So we have a predictive model here, which is highly accurate in that case. Maybe I should come to that in a moment. Let me first show you what the result of the overall process is in terms of usability. So now for the data where we did not know yet whether the customers will buy something or not if they receive my advertisement, I now get a prediction. And so I get a prediction of certain customers that will not buy, and of other customers that will buy. And obviously I can order that by the confidence of the algorithm. So I put those where the algorithm is very confident first. So this would be the guys that I write my campaign to. If you go further down, obviously the confidence values become smaller and smaller. And at some point you would probably reach a threshold where you would say it's not really worthwhile anymore to engage further, and maybe just write to the first 100, 200, 500 customers, whatever makes sense economically. So this would basically be the result. From a business perspective, you get a list of the customers and the confidence that the system thinks that they're going to buy if you send them a certain campaign. This is the main result. Obviously, the system gives you a prediction for its confidence, but how do you know how good the system really is on new data, on new customers, or on customers that did not receive such a campaign yet in the past, where I don't know whether the answer is yes or no? And for that, let me shortly explain the validation and then the validation results. So looking at the validation, if I double click on this one, you take it inside the operator. It has two parts. One is for training a model and the other one is for validating a model. So in this case, we have a so-called cross-validation that randomly splits the data from the past in 10 equally sized parts, uses 9 for training, and doesn't show the 10th part to the modeling technique. So the algorithm learns on 90% of the data, but I still have 10% left that the algorithm has not seen yet. When the algorithm is done with the modeling, we pass on the model that has been generated automatically. This apply model operator then takes that model and applies it to the remaining 10% and computes the performance. For example, the classification accuracy or precision or recall or other metrics, like how accurate is this model overall with all its predictions, or focused on the true buyers, or maybe focused on the non-buyers. So there's different criteria I may want to look at. And the cross-validation now repeats that 10 times. So each of the 10 parts becomes a test set once, and the 9 other parts are always used for training. So I have independent training and test sets. I repeat that 10 times, and then the system can automatically compute the average of the performance. And this is actually a very reliable estimate of how good the system will perform on new, previously unseen data of the same type. And then if we look at that particular learning algorithm here on this demo, we see that for the true responders, well, actually here the accuracy is not as good. It's just 42% on the true responders, but it's very accurate on the non-responders. So that means if I really believe the model, I will just catch 40% of the responders and miss 60% of the buyers. But I have only a little waste of resources. So obviously this is not the best learning technique. So we can play with the process, replace things. For example, here we could say, let's take another model, for example, a decision tree learner. Instead, it's just that easy. You drag and drop, remove it, or just deactivate it. And now I could rerun the whole process. And then you can see now it generated a different type of model where it tried to distinguish buyers from non-buyers using the attributes we have seen before. And obviously the activity of my customer is quite a good indicator how likely he is to buy. If he has been active in the last 4 weeks and logged in more than 6 times into my website, there's a very high chance that he's going to buy. And so if he's not logging in that often, then the next criterion that is looked at is the email. If it's a premium email, chances are higher that they're actually also buying something. If it's a non-premium but a free email, then there's other activities that may be indicating a buy decision. So this is just to give you a short idea of what such a model could look like. I also mentioned the indicators, so let's look at the chart to visualize them. I want to group by the attributes. I want to look at the weight, like how strong of an indicator is each attribute. And now I get a ranked list where I can see the type of email is a very strong indicator taken by itself, and also the login activity of the user. So those are the strongest indicator for a purchase decision. And maybe now I can use that insight to try to well, attract my users or my customers to my web page and thereby increase their connection to my company. That could be one logic. The other thing is I can use this knowledge implicitly by automatically generating models like a decision tree or a Bayesian statistical model like we saw before, or other models, and then automatically predict how likely they are to actually buy something, and then use that in a sorted way to select those that actually buy something. So this was just a little example, starting quickly with a template process. Let me go one level up again. I just changed the learner in here. Obviously, you can change the data source the same way. If you want to play with your own data, you can use such a template, put your data in there. And maybe before we continue with other templates, let's just have a quick look. How do I actually get my data into the system? So let's start with a blank process. There's different ways. So one way is you or one of your colleagues has already loaded a data set into the system. In that case, if it's in the repository, it's a known data set, I can just drag and drop it from here, connect the port, press the run button, and I can already see the data set. In this case, it's a very simple data set, 4 numeric attributes, 1 target variable. It's predicting the type of iris flower based on 4 different measurements of that particular flower. Here you could look, for example, at the value distribution. You would see, oh, we have 3 different classes, equally frequent. Or you could look at maybe the value distribution of A1, have that in detail. Or maybe you want to do some more charting on your own. Let's go, for example, for a scatter plot. And let's see if we can distinguish the classes. You can see we have 3 classes. Blue is iris setosa, we have iris vesicular, and iris virginica here. Obviously, the blue cases, the setosa cases, can be easily separated, even with this random choice of dimensions. But the green and the red cases are much more difficult to distinguish here. So now I could randomly play with those. Maybe A3 and A4 are better. And it turns out, yeah, this choice is better. Blue is even easier to separate. Green and red becomes also easier to separate, although there still is a little bit of an overlap. If I don't know which one is the best, I could just look at all combinations and let the system visualize that for me, and then have a quick look which combination is the best, and then go back to the previous plot and say, okay, I take a more detailed look at that one. You can also do three-dimensional plots if you feel like doing that. Obviously, you should select 3 different dimensions for it to make sense. Sometimes that may be helpful. There's a lot of other visualizations. Some of them make more sense on other types of data, so I'll show a few more later on. So the easiest way to load data is it's already in your repository. How do I get it into my repository? Okay, let's first store the data set, for example, as a CSV file, and then just put it here. Let's call it iris.csv. If I run the process, oops, a problem occurred. Okay. Maybe I should pick a different. Okay. Sorry for that. That's the risk with live demos. Let's not spend too much time on that. I don't want to waste your time. Let's rather pick something else simply easy to do, and let's just do that instead. Configuration should be as easy as possible. Okay. So now the process has run and the file has been written. So now let's assume I want to read in a file like such an Excel file or CSV file. How would I do that? Well, the easiest way is to drag and drop. So let me just open the directory where we stored that file. Start from scratch again. It's an empty process. The easiest thing you can do is just drag this file over here. And what you see now, automatically an import data wizard pops up and shows you what it can read. And now you can check the file and see the content of the file. And for example, you can decide first row should be the names of the attributes. The rest should be the actual data. You see that the type of the data is also automatically detected. So we have 4 real-valued numeric attributes. We have an ID attribute, which is polynomial. That means it's a string-valued attribute. And the same applies to the label. If I don't agree, I can change the type to something else. I can also change the role. For example, I could say, I want this to be a label. Label is the same as target variable. And you can see now it's marked as a special attribute. And next step, I can now specify a location where I would like to store the file. So let's just store it in my repository. Let's just make it simple. I just store it there. There we go. So if I now go back to my repositories, not to the sample one, which is delivered with the system, but rather to the demo folder, you can see that we have the iris here. Just drag and drop it. So once you have imported the file, it's as easy as if it had been in the sample repository. Same applies to CSV files or databases. Let me maybe just give you a quick idea of reading from a database, how that would work. Just go to read database, and then you have to specify if you're using a predefined database connection or a URL. Let's say you didn't define the database before, you would then select the type of database you want to work with. It provides the server information, like what's the IP address of the server, username, password, etc. And then it would be the same thing. So changing a data source within RapidMiner is really simple. Okay, let's take another data set to show you some more visualizations. So for example, let's take, oops, it's actually process. Let's go for the data set. Let's take a data set that has more attributes than the one before. Now we have 60 attributes, all of them numeric. And to give you some background, those are ultrasound measurements, and the task is for a ship searching water mines to classify the signals, these 60 measurements, whether they're a rock in the sea or whether they're a water mine. Obviously, you want to remove the water mines and be careful with them. For the rocks, you don't care so much. Obviously, now it's much more difficult than for the customer data we had before to recognize what are relevant attributes, which are not. We can, of course, look at the statistics, but to be honest, that doesn't tell me that much, just the value range here. So let's look at the charts. Since I have 60 dimensions, randomly finding good ones is probably not such a good idea. So let's look at another type of plot. That's called a deviation plot. You can see down here, for each of the 60 attributes, I have one dimension. And now I compute the average value for each of the rocks versus for each of the mines. The mines are red, the rocks are blue. And you can see that some of the attributes don't contribute as much information. They're almost the same on average. But you see that for other frequency ranges, like here around the attribute 11 or around the attribute 36, for example, there is some difference on average. So there is a chance that we can actually classify these in a better way automatically. So let's just try a tree, for example, that we saw before. And let's just see what happens. Now we can see, like we already guessed, attribute 11 or the range around it is very relevant. Then we saw the range around 36 is very relevant. And you can see that the system comes up with a model that's actually not too bad. Like if there's only one color in a leaf of the tree, that means it's a perfect classification on the training data. If it's mixed color, like down here, you can see that in this case, this leaf covers 190 cases in the training data. 97 of them were mines, so it's still pretty confident there, but there were 22 misclassifications that were actually rocks. So now we could try to fine-tune the model or work with it like that to just give you a quick idea of how accurate it is. We could do a validation like we saw before. You remember the cross-validation with the two inner processes. Actually, if you want to reuse some building blocks like that with maybe more complex process chains, maybe for data preprocessing, maybe for modeling, we actually have something we called building blocks. So I can save parts of my process as a building block. Or if I click on the background here, I can insert a building block. So let's just do that. We have a nominal classification task, classify whether something is a rock or a mine. So we need a nominal cross-validation here. Let's just drag and drop that in here. And now let's do the cross-validation instead of the tree building. And let's take a look inside. You see, the default already has a tree inside. It already has the model application. It already has the performance computation. So I don't need to do anything else. Just add the building block and I'm done. Now I can connect those again so I can see the results, press the run button, and now I do not only get the model, but I also get the expected accuracy. And I can see on the rocks, well, it's roughly 50-50, not too good. On the mines, well, at least 70% accuracy. Probably we can do better. So in that case, some pre-processing would help. Let's just do something as an example, discretizing data. And let's just split each numeric value range into 3 equally sized buckets of values, and let's just see if that improves the accuracy. You can see overall accuracy is now 76%, and if you look for the true rocks, went up from 50 to 71. For the mines, it's also pretty high. So actually, this little pre-processing step already improved results a lot. Now you might wonder, how should I know what to do? Like if you're not a data mining expert and you just have no idea what to do, well, if you look at the bottom of the screen, you see recommended operators. RapidMiner has a very big user community. We have more than 200,000 active users who use RapidMiner at least once a week. And we allow you to leverage the wisdom of the crowds. So every user who agrees to send their usage statistics, like what operators do they use and which are used together. This is collected centrally in our database, and then we build machine learning models on top of that. Similar to what you know from Amazon. If you buy a book at Amazon, Amazon starts to recommend people who bought this book also like these books. And that's a bit what we do here. You selected some operators already. If you look here, you have 3 different things, and actually inside the cross-validation there's more. And now, given a certain context, like on that process design level, you get recommendations of what other people have done in similar situations. For example, selecting attributes. Don't take all of the attributes, focus on the relevant ones if you have some domain knowledge. Or maybe set the role. Maybe you want to learn a different target variable. Or maybe to filter the data if you, for example, want to reduce the training data size, or you want to remove examples that you don't like for certain reasons, maybe focus on certain regions of your customers. And obviously, once you train a model, you want to apply a model. So these are things given in the context. Now let's go to a particular operator, for example, the decision tree. This has a lot of options you can vary to make it more flexible, more powerful for you. However, without expertise, it may be a bit difficult to set the parameters. So let's look at, for example, at the first one, the criterion to select what's the strongest attribute, the strongest indicator with regards to my target variable, to my label. Well, I can see what other people used in the situation. Most of them used gain ratio, which is a default. So I probably just stick with the default for now, unless I have a reason to change that or want to play. Same for maximal depth. What's the distribution there? And I can see most people use the value in the range between 20 and 29, which probably makes sense. If the depth of the tree is too small, it can't really differentiate the data fine enough, and it won't have a very fine-grained model. But if you overdo it, makes the tree too complex, first of all, it becomes very hard for a human to read, and also there's the so-called problem of overfitting. You actually make the model so fine-tuned that it's adapting to noise in the data, not only to the strong patterns. But of course, we want to generalize from the data. We want to find strong patterns. We don't want to model the noise. We want to model the patterns. So this is some indication. So the wisdom of the crowd provides you recommendations for operators as well as a parameter value. So that makes the process much easier. Okay, so we have seen how to get started with videos, with tutorials, how to import some data with drag and drop from, for example, CSV or Excel files, or how to use some other data source, for example, a database, although I didn't go through all the details to save some time. We saw how to do modeling, for example, to create a decision tree or a Bayesian statistical model. And to just give you a quick idea, if you're really into data mining and you like to play a lot with different techniques, you can see that we have more than 100 modeling techniques available here. And we have a marketplace similar to what you know from the iPhones, the iTunes store, or from the Android phones. We have the Google Play Store. We have a marketplace where our developers, but also third parties like universities, like other companies, provide extensions to RapidMiner. And so we seamlessly integrate, for example, modeling techniques from Beka, from R, from Python, and from other environments. And we have extensions that allow you to do not only standard data mining, but also time series analysis and forecasting, text mining, web mining, image mining, audio mining, and a lot more. And if you want to leverage that, all you have to do is click on extension here, go to the marketplace. Now it connects to our marketplace server, and then you can search for a particular topic. Let's say you want to do text mining, and then you can see now it's checking all the available extensions that deal with text mining. You see the standard RapidMiner provided text processing extension, but you also see partner extensions like Eileen is a company specialized on text mining and sentiment analysis, seamlessly integrates their solution into RapidMiner. And same, I mentioned that we integrate R and Python. If you look for scripting, RapidMiner is a quite visual interface, as you've seen. All you need to do is drag and drop. But sometimes, especially if you're an expert, maybe you want to use your own scripts, or maybe you have some legacy code you want to reuse in RapidMiner. It's easily possible. You just need to download the extension for Python, for R, and there's others for Octave, which is an open source version of MATLAB. So this is really powerful. It doesn't only provide you more than 100 modeling techniques, out of the box, but you have all these other options available for integration as well.